I'm Bill Hubsher.
And I'm Lori Meggs. On this episode of Focus on Marshall, we'll show you how high school and college students are aspiring to be the next generation of rocket scientists.
But first, we'll talk to the current generation of rocket scientists who are preparing to launch the Ares 1X, the test rocket that is the precursor to us going back to the moon. We're here in the office of the Deputy Mission Manager of the Ares 1X, Stephen Davis. And Steve, thanks very much for joining us today. A lot of people are familiar with the Ares 1 and the Ares 5, but what exactly is the Ares 1X?
It's the development test flight for Ares 1, and we're going to fly it in the spring of 2009.
So why do we have a need for an Ares 1X?
Well, there's challenges in building Ares 1. It's a very tall, thin rocket, and we're interested in understanding the dynamics, the control of the rocket through its ascent phase, its separation, and recovery of the first stage segment, which is also part of the Ares 1 system.
What specific things are you going to be looking for when you're watching and examining the data that is coming back from the rocket?
Well, we want to make sure that obviously it's controllable, so we'll be looking at that. We'll be looking at the loads that are on the vehicle, whether they're thermal, aerodynamic loads, forces, and those kinds of things. We're going to be looking at the overall performance of the rocket, and we'll be looking at also how the parachutes perform when the first stage is separated and the parachutes come out, so that the first stage parachutes into the water and we retrieve it.
So how does the Ares 1X then fit into NASA's overall mission?
Well, with Ares 1 being part of the constellation set of launch vehicles, Ares 1 and Ares 5, the Ares 1X is that development test flight for Ares 1, which allows it to move forward with greater confidence as we go through the design.
Okay, thanks a lot, Stephen.
Thank you.
We're joined now by Chris Calfee, and he is the manager of the first stage for the Ares 1X. And Chris, if you would, tell us a little bit about what you and your team are responsible for when it comes to the rocket.
Sure. My team is responsible for providing the first stage portion of the vehicle. The first stage portion will provide the propulsion that will send the rocket on its way.
All right, and you've got a model here of the Ares 1, which is, of course, closely resembles the 1X. Show me exactly what it is we're talking about here.
We're talking about the tip of the nozzle all the way to the top of the frustum. The frustum is the piece that provides the transition from the first stage to the upper stage simulator.
Now, how does one go about designing a brand new rocket like this?
Well, actually, it's not all brand new. It's a legacy hardware, solid rocket boosters, which are used on the shuttle today, up to it's a 4-segment rocket. We're adding a 5th segment simulator. It won't be fueled. It's just to provide the outer mode line to represent the length of the vehicle. And then we'll have the parachutes that will recover the vehicle.
So we're testing that part as well.
Yes, we are. Recovery is a primary objective for 1X.
So, Chris, what do we hope to see on launch day?
What we'll see is about a 2-minute burn of the first stage. And after that, we'll separate the upper stage piece of the rocket. Will go further off and splash down further out in the ocean. The first stage piece will re-enter. The parachutes will deploy. It'll splash down. We'll recover it with the ships that recover the shuttle boosters today. We'll haul it back into port.
And then comes the examination phase.
That was the fun part.
All right, thanks a lot, Chris.
You're welcome.
I'm here now with Matthew Fifield, and he is a senior at Utah State University in Logan, Utah. And Matthew, just tell me about how you got here today.
Well, we flew down from Logan, Utah. This is Utah State's first entry into the USLI competition here in Huntsville, Alabama. We had a really great experience today. We had a successful launch of a Contrail L800 motor, successful dual deployment of our parachutes. We had a small avionics problem. Our flight computer thought we were 10 times the altitude that we were actually at, and so we designed a student-built air brake deployment to control our altitude, and since it thought we were a lot higher than we actually were, it deployed for too long, and we dropped our altitude a little more than we had anticipated. But we had a very successful time out here. It was a really great experience.
So let's back up a little bit. What all went into that? You just started last week building it, right?
No, this has been a full-year project. There are 10 mechanical engineering students that are all seniors on the project. We're using it as our senior project. We also have the help of some electrical engineering students and one graduate student. And we've spent 2 full semesters of coursework on the rocket.
And you have to submit a proposal, and then what else?
Well, it starts from the proposal. Every school has to enter a proposal and be accepted into the competition. Once that is accepted, then you can start ordering hardware and going into your final design. And there are a lot of milestones, just like any NASA project. You have a PDR and a CDR, and then a flight readiness review as you go along, that we had to present our rocket and our documentation as we go along.
Now, I notice you bring in the NASA aspect. You're wearing the cap. Is this something, are you networking here?
I'm really trying to. I actually have applied to work at ATK in Utah, and I really hope to get involved in the Ares 1 project. We got to tour Marshall Space Flight Center. It's been a really great experience for us to get down here and network with some of these folks.
All right. Well, your launch was fabulous. Good luck to you.
Thank you. We appreciate that.
I'm here with Rudy Gutowski, and he is a NASA Administrator's Fellow with the Marshall Center. And Rudy, just tell me what that means to be an Administrator's Fellow.
6 staff scientists at NASA centers are chosen each year to participate in the Administrator's Fellowship Program. This is on the basis of a proposal that's written by the participants, or by the applicants actually, and also includes letters of recommendation from their supervisors and also from the host institution that scientist would be going to. I should also say that 6 university faculty at minority serving institutions also get to come to NASA centers and work on research within the same program.
And you have chosen Fisk University. Tell us your role with them.
At Fisk University, I was initially working in the chemistry department, developing some curriculum there. We developed what's called an inquiry laboratory for the general chemistry class. In that sort of a activity, the students are given a rough framework of a problem, and they try to develop a solution to that problem using some chemistry knowledge.
Now, we have the University Student Launch Initiative today. Tell us about your role with that today.
Well, the University Student Launch Initiative is an opportunity for students at universities to build rockets and to fly them. Specifically, the rockets are to go to an altitude of 1 mile, 5,280 feet, and be recoverable and be used again. Also, they're to have a scientific payload. In the case of our rocket, we'll be measuring temperature. We can see the ground from the rocket as there's a camera on board, but probably what's more interesting is that we're measuring vibration from the motor. And also, we have joined with a science magnet school, Martin Luther King High School in Nashville, Tennessee, and given them basically space on the rocket, but giving them discretion as to how they were going to utilize that space. And what they're doing is what they've done is they built a robot that will be carrying aloft, and then after the rocket lands, the robot will be expelled and it will run around. And I think it's actually measuring some temperature in various zones across the ground.
And these students are learning skills that we are looking for. Why is this so important to NASA's mission to get these students involved in events like this?
Well, as we probably know, the folks at the agency are getting older and going to be retiring, and we're going to need to expand the workforce, especially with the exploration activities that we're wanting to take on. And therefore, we will need these new students to come and actually, be interns and then later on to work there. In the case of the university here, we've had 2 students be accepted as interns. One of them in their second year. They're coming back a second year. We've also have one student who, because of this experience, is applying for positions, fresh out positions at Marshall, because he would like to work at Marshall Space Flight Center.
Well, I know they are very lucky to have you as a mentor. Thank you for talking with us today.
It's been a pleasure. Thank you very much for the opportunity.
Bill, I'm very impressed with those students.
And I'm sure we'll see a few of them walking the halls of Marshall someday.
We hope so. Join us next time as we focus on Marshall.